Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss paper 4, further statistics, May-June 2023, paper 41. Let's take a look at the questions. Number 1. The length of the leaves of a particular type of tree are normally distributed with the mean mu cm. The length xcm of a random sample of 12 leaves of this type are recorded. The results are summarized as follows. And the question wants you to find the 95% confidence interval for the mu. So for this question, the very first thing you need to do is to find the mean. Okay, the bar x, it will be 91.2 divided by 12. Just press the calculator and then you get 7.6. After that, you find the unbiased estimations of population variance. You will get 1 over the 11, 695.8 minus the 91.2 square divided by 12. So again, press the calculator and then you get this answer as a 0.24364. I give extra 2 more significant figure, make our answer more accurate. Okay. Then now I want to find the t value. So the t value will be 0.975 and then the degree of freedom is 11. So just look from the formula booklet MF19 and you get this will be 2.201. Okay. So we need to use 97.5%, although the question give you 95% here, because this is a confidence interval and it's two-sided. Okay, so it's two-sided. So what you need to do is you need to find this value so that it will give you the shaded region here, or the shaded, the probability here is a 97.5%. Okay, so that this part is 2.5%. Okay. So because the 95% actually is two-sided, 95% is two-sided. So therefore, actually, this one is two-tailed. This one is 2.5. And this part over here inside here is 95%. Okay, so that is the reason you need to find the value from the table, looking for the 97.5%, not looking for 95%. Okay, so now we have all the things that we need. Now it's time for us to find the 95% CI for the mu. Will be the bar x plus minus the t value. T value. And then square root multiplied by the square root of s squared divided by n. Okay, so this is the formula. So you just need to put in 7.6 plus minus of 2.201. 2.201 square root of 0.24364 divided by 12. Just like that. So just show this value and then you just press a calculator and your answer will be in the interval from 7.29. Leave the answer in 3 significant figure to 7.91 inclusive. So this will be the answer for the question number 1. Done. So now we move to the question number 2. Okay, so now question number 2. The children at 2 large schools P and Q are all given in the same puzzle to solve. A random sample of size 10 is taken from the children at school P. Their individual times to complete the puzzle give a sample of 9.12 minutes and the unbiased variance estimate of 2.16 minutes square. A random sample of 12 of size 12 is taken from the children's school Q. Their individual times, X minutes to complete the puzzle are summarized by the following. Okay, where the bar X is the sample mean. Time to complete the puzzle are summarized to be normally distributed with the same population variance. Okay, so test at 5% significant level, whether the population mean time taken to complete the puzzle by children at school P is greater than the population's mean time taken to complete the puzzle by children at school Q. Okay, so we need to do hypothesis tests. So first of all, we build the hypothesis. So the null hypothesis is that the population mean Okay, the population mean time. So over here, we can just say that the mu P equal to the mu Q. Okay, against the population mean time. So over here, because they mentioned they is greater, they use the term greater, so the mu P will be greater than the mu Q. Okay, so we just write like this, mu P greater than the mu Q. So this is our hypothesis alternative. Now hypothesis and alternative hypothesis. Now that we want to, this is representing the X. So for the data for Q is representing X. So the data for P, I will use Y to represent it. Okay, so first of all, we to find the bar X. Bar X is this value, 99.6 divided by, what is the N? N is a 12. Okay, so you just press the calculator, you get 8.3. Then the unbiased estimations of the population variance, I put it as a SX square. Okay, so SX square is a 1 over 11. Straight away apply the formula. Okay, this one is a 21.5. So you need to know the formula. So the formula that I'm using will be sigma of X minus the bar X square over N minus 1. I just apply this formula directly. Okay, so just press a calculator and then you get this one as a 1.9545. I leave the answer with 5 significant figure so that it will make my calculation more accurate. Okay. Then for the bar Y is given as a 9.12 in the questions, 9.12, and the SY square also in the question given as a 2.16. So we just copy down only. Okay. So this is the data for the Q. This is the data for the P. Then we are looking for since our null hypothesis and alternative hypothesis will be like this, so we need to take the bar X. We need to take the bar Y minus the bar X. Okay, we want to take the bar Y minus bar X. Okay, so we take the bar Y minus the bar X. It will be 9.12 minus the 8.3. Okay, press the calculator, you get 0.82. Then after that, the combine the variance together, these two variants combined together as a combined variance. So the combined variance will be, the combined variance will be 11 multiplied by 1.9545 plus the 9 multiplied by 2.16 divided by 12 plus 10 minus a 2. Okay, 12 plus 10 minus 2. Okay, so I'm applying the formula of nx of the sx square. Sorry, nx minus 1. Okay, I'm applying this formula plus the ny minus 1 sy square, and then divided by the nx plus ny minus 2. I apply this formula. Okay, so but I just straight away write down the value. Okay, so then after that I just press a calculator. So if you press a calculator, then you get the answer as 2.046. Okay, then now I want to find the critical value. So the critical value will be 0.95. This is a one tail test. This is a one tail test. So the question say 5% significant level. 5% significant level, that means it's 95% of the confidence level. Okay, so this one is 95%, one tail. Then your degree of freedom will be this whole thing, 12 plus 10 minus 2. 12 plus 10 minus 2 is actually 20. So your degree of freedom is 20. Use the formula booklet MM19, then you can get the answer as 1.725. Okay, so this is the critical value. Now we're looking for test statistics. So for the test statistics, the T will be the bar Y minus the bar X minus the mu P minus the mu Q. divided by the square root of the s square of 1 over nx plus 1 over ny. Okay, so we're supposed to use this formula, but actually I no need to write down this. I straight away just implement the value inside, just apply the value inside will do. So no need to show this formula anymore. So over here, we can just write down this as a 0.82 minus a 0. Okay, so remember that this is a bar y minus a bar x. This is actually the mu p minus a mu q. Mu p minus mu q equal to 0 is coming from here. It's coming from here. Okay, mu p minus mu q equal to 0. Okay, so this is the this is how we get the value. This is how we get the value. So this one I straight away write down 0.82 minus a 0 divided by the square root of the 2.046, 1 over the 12 plus 1 over the 10. Just formula directly. Press the calculator, then your answer will be 1.339. Okay, so now we want to make a decision. So in order to make the decision, you compare the t with the critical value. Okay, you compare this with the critical value. So this one, you just put modulus for both. And then you can see that after you modulus both sides, the t and the critical, the ts and the cv, so you can see that this is actually less than a critical value. So if it's less than critical value, that means you just accept H now. Okay, so now conclusion. There is insufficient evidence to support that the mu p greater than the mu q. Just like that. Done. So this will be the answer for this question number 2. Okay. Okay, now we take a look at question number 3. A random sample of 50 values of the continuous random variable x was taken. These values are summarized in the following table. Okay, so these are the table given. Okay, so these are all the value, all the observed frequency. So it is required to test the goodness of fit of the distributions with a probability density function. So they give you the PDF given by this. Okay, these are the PDF. And then the expected frequency correct to 4 decimal places. They mentioned that this is correct to 4 decimal places. So the value for A and B, we also follow the standard, make the answer as correct to 4 decimal places. Okay, then we want to show how to get the A equal to the 4.6007 and also want to find the value B. So this one is actually just need to do integration. So we just need to know the formula of how to find the expected value. Okay, so for A, it's actually 50. This is the 50 is the n. Okay, how do I know it's 50? Because this is the n. Multiply the probability between this. Okay, so the probability between these two values is actually integrate from 1.5 to 2. And then the function will be this function. 1 over 24 multiply 4 over x squared plus x squared dx. So this one, actually, we have no shortcut. We just direct integrate. But first of all, the constant here and the constant here, I will bring it, join together, make it become 1. 50 over 24. Simplify 50 over 24. Both can divide by 2. I get 25 over 12. Then inside here, I just need to integrate. Okay, inside I just need to integrate all this. Integrate 4 over x squared, you get negative 4 over x. Then x squared, you get x cubed over 3. Then 1.5 to 2. So basically, just do like this, you can get the answer as stated. So this one is a 4 over 2 plus the 8 over 3 minus the negative 4 over 1.5 plus the 1.5 cube over 3. Okay, just do like that. Then press the calculator directly. Then you can see that your answer will be 4.6007 shown. They want 4 decimal places, the decimal. Okay, so same thing happened for the B. So for the B, we also do the same thing. So this time B is also 50 multiplied by integrate 3 to 3.5. 1 over 24 of the function 4 over x squared plus the x squared. So for this time, since we're going to do the same thing, it's just that the value here, the lower limit and the upper limit, the value are different. So actually we can just copy the result from the previous part. I just need to copy this result. Just need to copy this result by changing these two value from 1.5 to 2 become 3 to 3.5. Just like that. Okay. So to save time, so we can just direct apply this result. It will be 25 over 12. And this one is negative 4x plus the x cubed over 3 from 3 to 3.5. So over here, you just press the calculator. Okay, just press the calculator, then substitute in. .5. This one is 3.5. 3.5 cubed over 3. Okay. Wait for a while. Okay. So now over here is 3.5 cubed over 3 minus this one has a negative 4 over 3 plus the 3 cubed over 3. Then press the calculator, you can get the answer as 11.420. Okay. 4210. But you can see that actually we have another way to do it. Okay, so this is actually this is quite a formal way. This is quite a formal way, but this way actually a bit troublesome because you need to do the substitution and find the value. So I will recommend you another way. Okay, I recommend you another way. Alternative B, it can be the total 50 minus all of the value here. Okay, minus all the value here, then you can get the B because the total of this will become 50. Okay, so this is another way. Alternative, the B can be do it in this way. So just take 50 minus a 4.4271 just write down plus the 4.6007 plus the 6.128 plus the 8.4549 plus the 14.9678. Okay, so at the end you will also get the answer 11.4210. Okay, so that is the answer for the part A. So now we move to the part B. Carry out a goodness of fit test at 10% significant level to test whether F is a satisfactory model of the data. Okay, so we also need to do the chi-square test. We need to do the chi-square test, hypothesis test. Now hypothesis is F is a satisfactory model. Okay, it's a satisfactory model. Okay, versus F is not a satisfactory model. Just like that. That is your first step. Then after that, we need to build the table because we need to find the observed frequency and the expected frequency. Okay, so we need to have OI and EI. So for this case, your interval, this is the EI, this is the OI. Okay, So actually our OI and EI is all here already. So we just copy down only. So to save time, I direct write the answer. I direct give you the result. Two 2.5. 2.5 to 3. Yes. Then 3 to 3.5. Then 3.5 to 4. Okay. So this one actually I just need to copy down the result that I have in the part A. Okay. But this I have to combine, okay, because this one is less than 5. Okay. This one is less than 5, right? These two actually less than 5. Okay. Both of them less than 5. So if less than 5, that means that both of them had to combine together. So therefore, the value will be these two combined from 1. So this one, it will be combining them together, it will be 1 to 2. Okay, it will be 1 to 2. Okay, yeah. So need to combine, I need to show that you combine them. Then this one is this one's just copy down, the rest just copy down, 1285. Then 8.4549. Then this one will be 11.4210 and 14.9678. Okay, so the rest actually just copy down. Only the first two row, first two column need to combine together. Okay, so now done. Then for this case, we can find the degree of freedom. So the degree of freedom, it will be, you have 5 column minus the 1. So you get a 4. Okay, this is your degree of freedom. Then your critical value. So your critical value will be chi square. It's 10% significant level. 10% significant level is the same as 90% of the confidence level. Okay, then this degree of freedom is 4. Just check from the formula booklet MF19, and you get this one as a 7.79. Okay, so now your test statistics. So test statistics will be a little bit troublesome. So the formula for test statistics is OI minus the EI bracket square. OI minus the EI bracket square divided by EI. Okay. Great. So this is the formula. So I just direct press each and every one. I just use the formula, and then I press it. So I just give you the answer right away. So since the value is given in 4 decimal places, so I will do the same thing as well. I will give this as a 4 decimal places, 0.5715 plus a 0.7661. Okay, so this one you can try to press the value yourself from the calculator to double confirm the answer is correct or not. So this one, it will be, the last one will be 9885. Okay, so now after that, total up everything, also using calculator. So this will be a critical value. This will be critical value. So now if you compare your test statistics compared to the critical value, who is bigger? So if you compare, you can see that your test statistics is actually less than the critical value. So since it's less than critical value, therefore you accept H now. So now conclusion. So conclusion is there is sufficient evidence to support that F is a good fit for the data. Okay, done. So that will be the answer for the question number 3B. Just like that, done. Okay, now we take a look at question number 4. A random sample of 13 technology companies is chosen, and the number of employees in 2018 and 2022 are recorded. Okay, so these are the table and the data given. A researcher claims that there has been an increase in the median number of employees at technology companies between 2018 and 2022. A. Carry out a Wilcoxon match pairs sign rank test at 5% significant level to test whether the data supports this claim. Okay, so to save time, I just write down the data here vertically. And before we do the hypothesis test, we will need to fill up this table. This D is I'm taking the 2018 minus the 2022. Okay, you can take 2022 minus 2018. Okay, you can decide it on yourself. But before that, maybe we can write down the hypothesis first. So the population median 2018 is equal to the 2022, no difference. Okay, versus the population median for the 2018 is less than 2022. Okay, so this is what I decide. So if I decide it like this, that means I will take the mx minus the my less than 0. Okay, so I will take the 2018 minus the 2022. So just minus it, just use your calculator, minus it, you get -2, -5, -1, 6, -42, -11, 3, -7, -20, -12, 8, 10, and -50. Okay, so after you have list down the difference, then you just put the rank P and Q. P is for positive value, Q for negative value. So you will have this one as the 1, 2, and 3, 4, 5, 6, then 7, 8, 9, 10, 11, 12, and 13. Okay, so total 13 of them. Okay, so these are the difference between the rank of positive rank and negative rank. So just we need to find the sum. So the sum will be 23 here, and the sum here will be 68. Okay, so now we are ready to do the Wilcoxon test. Okay, we need to find the critical value. So the critical value just need to search from the formula booklet MF19. Okay, so you can see that the CV critical value is 21. Then the test statistics is the minimum between two value here, 23 and 68. Okay, so the test statistics is actually 23. So the test statistics is greater than the CV. Okay, the test statistics is greater than the critical value. So therefore, you accept H num. Okay, so now conclusion. There is insufficient evidence to support that the median number of employees there's an increase in the median number of employees in technology companies between 2018 and 2022. But usually we don't need to write so long. We just need to support that the mx is less than the my. Just like that. Okay. Or you can say that to support the researcher's claim, because the researcher claims that researchers claims that there's an increase in the median number. So you can just say that to support the researcher's claim. Okay, you can change it into this way. Okay, that's all. So this will be the answer for the 4A. Okay, so now we move on to the part B. Okay, for part B. The researcher notices that the figures of company G has been recorded incorrectly. In fact, the number of employees in 2018 was 32. The number of employee in 2032 was 35. Okay, so this company G. So for company G, they find out that, oh, this is wrong. So that means this one have to be, it's supposed to be 30. Oh, the two numbers supposed to be swapped. So if these two numbers supposed to be swapped, if the two number here supposed to be swapped, then you get -3. If you get -3, then your 3 is supposed to be here. Then the total here will be different. Total here will be different. Total here will become 20. This one will become 71. Okay, so this is what is given. Okay, so for part B, you just need to, no need to draw the table again, just need to say that, okay, the sum of B, just need to mention that the sum of B just now is become 20, and the sum of Q has become 71. The test statistic still, the critical value still remain the same. The critical value is still 21, but the test statistic now is 20. Okay, so the test statistics is less than the critical value. Okay, this one is you reject. Page now. Okay, so we need to explain with numerical justification whether or not the conclusion of test in part remain not already not the same anymore lah. Okay, so we just say that therefore change in conclusion. Okay, just say that, just mention like this will do. That is the answer for the part B. Okay. Okay, now we take a look at question number 5. Harry has 3 coins. So the first coin is, one coin is biased so that when it is thrown, the probability of obtaining a head is 1/3. The second coin is biased so that when it is thrown, the probability of obtaining a head is 1/4. The third coin is biased so that when it is thrown, the probability of obtaining head is 1/5. The random variable x representing the number of heads that Harry obtains when he throws all the 3 coins. Okay. If you want to find the PGF, the probability generating function, but to find the PGF, usually we will need to build the probability distribution table. So we have x here. The discrete random variable for the x here will be a 0, no head, 1 head, 2 heads, and 3 heads. So we need to calculate the probability for each and every one of them. So for Bx equal to 0, none of the coin will obtain head. That means all the 3 coins at tail, it will be 2/3, multiply 4/5, 3/4. Then the third coin is 4 over 5. So just press a calculator, you get 24 over 60. We can actually simplify it to become 2 over 5, but I don't plan to do so because I want to make all the denominator all equal to 60, so that it's easier for me to do the calculation. So I remade it as a 24 over 60. However, if you want to simplify them become 2 over 5, that is okay. Then px equal to 1. Px equal to 1, that means one of the coin is head, the rest are tail. So it can be 1 over 3, multiply 3 over 4 plus 4 over 5, or 2 over 3, the second coin is a head, the first and the third coin are tail. Then or the first coin is head, the second coin is also, so the first coin is tail, the second coin is also tail, and the third coin is a head. Okay, so you get a total of 12 plus 8 plus 6. 12 plus 8 plus 6, you get 26. Okay, then I straight away jump to px equal to 3. Easier to calculate. 1 over 3 times 1 over 4 times 1 over 5. I get 1 over 60. Then for the px equal to 2, that will be easier. I just take 1 minus the rest of the 3. I no need to do again the probability. Just take the 1 minus this, and this 3. Okay, then I can get the answer for px equal to 2. So this one, it will be 24 over 60 plus the 26 over 60 plus the 1 over 60. You get 9 over 60. Okay, this one is 9 over 60. Okay, then therefore your PGF is equals to the 24 over 60 plus the 26 over 60t to the power 1 plus the 9 over 60t to the power 2 plus the 1 over 60t power 3. That is your PGF. Done. Then part B. Isaac has 2 fair coins. The random variable y is the number of heads that Isaac obtained when he thrown both of his coins together. Z is the total number of heads obtained when he throws 3 coins and Isaac throw 2 coins. Okay, so first of all, we need to find the PGF for the y. Okay, so y is the number of heads obtained for the 2 fair coins. The coins are fair over here. Coins are fair over here. So this just make it like that. Then so probability for getting none of the coin is head. That means it's a 1 over 4. This one is 2 over 4. This one is a 1 over 4. This one is quite straightforward. We can actually direct write down this. Then your GY will be 1 over 4 plus 2 over 4t plus 1 over 4t squared. Okay. Then they give you that Z is X plus Y. Then GZ T is equal to the GX plus YT is equal to the GX multiplied by the GY. So it's equals to the 24 over 60. Okay, is equal to this. Multiply to this. Okay. So I will take the factorize the denominator out. The denominator is 1 over 240. Okay. So the denominator will be like this. Then to save time, actually, I just expand directly and give you the final result. So You can try to expand yourself. So to save time, I straight away give you the result of the expansion. 45t cubed plus the 11t to the power 4 plus the t power 5. That will be the that will be the answer for the GZT. Okay, just like that, done. That will be the answer for the part B. Okay, then move on. We have part C. Use the BGF for the Z to find the expected value, to find the mean. Okay, that means we want to find the Z. So to find the EZ, we need to differentiate first. So from the result here, just need to differentiate all of them here. So differentiate this, you get 74, 170t. Okay. Then 135t squared plus the 44t cubed plus the 5t to the power 4. Okay. Then your EZ will be the GZ prime of the D is equal to 1. Then you get this 74 plus 170 plus 135 plus 44 plus 5. Press a calculator. Then you get the answer as 428 divided by 240. Then you can simplify them, become 107 over 60. Or you can give them in decimal place to 3 significant figure. That will be the answer. Okay. Zero 7 divided by 60. Yeah. Okay. So this is the answer for the part C. Done. And move on. Okay, now we are going for the question number 6. The continuous random variable x has a probability density function f given by following. We want to find the CDF. So to find the CDF, as usual, we will integrate them from 0 until x, 3 over 38, e power of half x, plus 4e power of negative half x. The 3 over 28 I take out. This one integrate directly. Okay, then replace the value inside. And you get this. Minus the 2 minus the 8. Then at the end, your answer will be 3 over 14. E power of half x minus the 4e power negative half x plus a 3. So therefore, your BGF 0 for the x less than 0. This one for the x greater than 2 ln 3. For your x between 0 and 2 ln 3, just copy down this result inside. So your answer here will be 3 over 14 e power x over 2 minus a 4e power negative x over 2 plus 3. Okay, so that will be the answer for the part A. Now, move on. We want to do part B. Part B, they want to find the PDF for the Y. So first of all, we need to find the CDF for the y. CDF for the y is by less than equal to y. Okay, so less than equal to y, change your y to become e to the power of x over 2. So this will make it become x is actually less than 2 ln y. Then this one, it will be the same as the f 2 ln y. So f2 ln y, just change all the f here, all the x here become 2 ln y. All the x here become 2 ln y. Just need to follow. So all the x here, copy down the whole thing, just change the x become 2 ln y will do. So this one, it will be, I think I just copy down this one first. I don't need to find the piecewise function yet. So this one is 3 over 14. E power of 2 ln y divided by 2. So it's a ln y. Minus a 4 e power negative 2 ln y over 2 is negative ln y plus 3. So we need to understand that e power ln y is equal to y. We need to know this result. So this one is a 3 over 4 of y minus a 4 over y plus a 3. Okay, so this will be my p y less than equal to y. So my gy will be this. I write them in the CDF form. P over 14 y minus a 4 over y plus 3. So this is for the, this one is, I need to change the x become, need to change all the x become ln 2 ln y. Okay, so this one is 2 ln y, 2 ln 3. This one will become 2 ln y greater than 2 ln 3. Okay, so we simplify them. This part already done. Just the domain need to simplify further. So domain we simplify further. If you let this equal to 0, you get the y is equal to 1. So this one is y less than 1. This is your y between 1 and 3. This one is your y greater than 3. So this is your CDF. But we are not looking for CDF. We need to have PG. We want to find PDF. So in order to get PDF, we must have a CDF first. Then, therefore, my PDF. Differentiate this, you get 3 over 14, 1 plus 1 minus, that's plus, because I need to differentiate, 4 over y squared. This one is 0 for other y's. This one is for 1, 2, 3, inclusive. Okay, done. That will be the answer for the part B. And move on. Part C. The 30th percentile of y. The 30th percentile for y, just need to take the CDF, the GY, you make it become 30%. 30% means 0.3, 30 divided by 100. So just take down the formula, the expression. Okay, like this. So your y minus a 4y plus 3 is equals to 1.4. So multiply 5. You get 5y squared minus a 20 plus the 15y equals to 7. So you get 5y squared plus 15y minus a 27 equal to 0. Oh, I have made a mistake. It's a 7y. So it's a 5y squared plus 8y minus a 20 equal to 0. Factorize it. Oh, 5. I think cannot factorize it. Let me try to use calculator to solve it. Okay, so we cannot factorize it. Huh? But there's no need for us to use the quadratic formula as well. Just need to press a calculator directly. So your answer will be 1.35. And another one will be negative 2.95. For the negative 2.95, we ignore it. Okay, we ignore it because of the reason that the y must be between 1 to 3. The y must be between 1 to 3. Okay, so therefore your answer will be only y equal to 1.35. Done. Okay, and now we want to find ey power 4. To find ey power 4, is actually just take the function, multiply the function PGF, the PDF for the y, this is the PDF for the y. Take this function, multiply by y to the power 4, and then integrate from 1 until 3. So just take the function, multiply by y power 4. Okay, just like that. Then expand, simplify. I take the 3 over 14 out. Y power 4 plus a 4y squared dy. So this one is a y power 5 over 5 plus the 4y cubed over 3 from 1 until 3. So quite straightforward actually. Just substitute the value in 243 over 5 plus the 36 minus a 1 over 5 plus the 4 over 3. Then just press the calculator. You can just direct give me the answer in decimal. Your answer is a 17.8. 3 significant figure, just like that. Done. So this will be the answer for the part D. And this will be the last questions as well. So we have completed this paper. I stop the video here.